As part of a pilot program, a biotechnology company wants to integrate data files from its on-premises analytical application with AWS Cloud via an NFS interface. Which of the following AWS service is the most efficient solution for the given use case? You can see there are 4 options. This is option 1, this is option 2, this is option 3, this is option 4. Okay, and you have 10 seconds time to answer the question. Your time starts now. Time up. Now let us analyze the answers. Option 2, AWS Storage Gateway, Volume Gateway, is incorrect because it's used for block level storage, not file level NFS interfaces. So option number 2 is the wrong answer. Option 3, AWS site to site VPN. This option is also incorrect because it's used for networking, not storage integration. Okay, so option number 3 is also the wrong answer. Option 4, AWS Storage Gateway or Tape Gateway, is incorrect because it's used for archiving data to virtual tapes, not integrating with NFS interfaces. Okay, so option number 4 is the wrong answer. Option 1, AWS Storage Gateway to File Gateway, is correct because it provides an NFS interface for integrating on-premises apps with AWS Cloud Storage. Okay, this is why option number 1 is the correct answer. Got it? Let us move to the next question. A high performance computing application needs storage that can provide 1,35,000 IOPS. The storage layer is replicated across all instances in a cluster. What is the optimal storage solution that provides the required performance and is cost effective? You have 4 options again. This is option 1, this is option 2, this is option 3, and this is option 4. You have 10 seconds time to answer the question and your time starts now. Time up. Now let us analyze the answers. Option 1, use Amazon S3 with byte range fetch. This is wrong because Amazon S3 is designed for storing and retrieving large scale data with high durability. However, it's not optimized for high IOPS. It works well for sequential reads or writes but cannot meet 1,35,000 IOPS. S3 is unsuitable for applications requiring ultra low latency or extremely high performance. Okay, so this is the wrong answer, option 1. Option 3, use Amazon EBS provisioned IOPS volume with 1,35,000 IOPS. This option is also wrong because while EBS provisioned IOPS volumes can achieve high IOPS up to 2,56,000 for IO2 Block Express, they are significantly more expensive than Instant Store. Given the cost effective requirement in the question, this isn't the best choice. Okay, so option number 3 is also the wrong answer. Option 4, use Amazon EC2 enhanced networking with an EBS HDD throughput optimized volume. This option is also wrong because EBS HDD volumes are designed for sequential throughput rather than higher IOPS. Okay, they cannot reach anywhere near 1,35,000 IOPS, making this option unsuitable for the given performance needs. Okay, so option number 4 is the wrong answer. All right. Option 2, use Amazon Instance Store. This option is correct because Instance Store is a high performance temporary storage directly attached to the physical server hosting an EC2 instance. It provides extremely high IOPS, well beyond 1,35,000, making it a perfect fit for HPC applications. It's also cost effective since it comes included with EC2 instances at no additional cost. Limitation is the data is temporary and tied to the life cycle of the instance. However, since the storage is replicated across the cluster, this risk is mitigated. Okay, this is why option number 2 is the correct answer. Got it? Let us move to the next question. A company delivers content to subscribers distributed globally from an application running on AWS, and the application uses a fleet of Amazon EC2 instance in a private subnet behind an application load balancer. Due to an update in copyright restrictions, it is necessary to block access for specific countries. What is the easiest method to meet this requirement? So you have got again 4 options. This is your option 1, option 2, option 3 and option 4. Okay, you have 10 seconds time to answer the question and your time starts now. Time up. Now let us analyze the answers. Option 1, use a network ACL to block the IP address ranges associated with the specific countries. This option is incorrect because network ACLs can block IP address ranges, but they are not the easiest method. You would need to find and update the IP address ranges for the blocked countries, which can be complex. So we don't take that answer. Option number 1 is incorrect. Option 2, modify the security group for the EC2 instances to deny incoming traffic from blocked countries. This option is also incorrect because modifying the security group for EC2 instances would affect all incoming traffic, not just the traffic from the blocked countries. This approach isn't targeted enough. Okay, so option number 2 is also the wrong answer. Option 3, modify the ALB security group to deny incoming traffic from blocked countries. So ALB means application load balancer, by the way. This option is also incorrect because modifying the ALB security group would also affect all incoming traffic, not just the traffic from the blocked countries. Okay, so this approach isn't targeted enough. Okay, so option number this one 3 is the wrong answer. Option 4, use Amazon CloudFront to serve the application and deny access to blocked countries. This option is correct because Amazon CloudFront, using Amazon CloudFront to serve the application and deny access to blocked countries is the easiest method, because CloudFront provides a feature called geo restriction that allows you to easily block access to specific countries. This approach is targeted, easy to implement and scalable, right? So option number 4 is the correct answer. Got it? Let us move to the next question. A web application that allows users to upload and share documents is running on an single Amazon EC2 instance with an Amazon EBS volume. To increase availability, the architecture has been updated to use an auto-scaling group of several instances across availability zones behind an application load balancer. After the change, users can only see a subset of the documents. What is the best method for a solutions architect to modify the solution so users can see all the documents? You have again got 4 options for this question. Option 1, option 2, option 3, option 4. And you have again got 10 seconds time to answer the question. Your time starts now. Time up. Now let us analyze the answers. Option 1, use sticky sessions with the ALB to ensure users are directed enough to the same EC2 instance in a session. This option is incorrect because sticky sessions ensure users are directed to the same EC2 instance during a session. However, this doesn't solve the issue of users only seeing a subset of documents, as the documents are stored on individual EBS volumes, right? So option number 1 is the wrong answer. Option 2, run a script to synchronize the data between Amazon EBS volumes. This option is also incorrect because synchronizing data between EBS volumes would be complex and might lead to data inconsistencies, right? So additionally, this approach doesn't scale well. Option number 2 is the wrong answer. Option 4, configure the application load balancer to send the request to all servers. Return each document from the correct server. This option is also incorrect because configuring the ALB to send requests to all servers and returning documents from the correct server would be complex and inefficient. This approach might also lead to performance issues. Okay, so option number 4 is the wrong answer. Option number 3, copy the data from all AWS volumes to Amazon EFS, modify the application to save new documents to Amazon EFS. This option is correct because copying data to Amazon EFS and modifying the application to save new documents to EFS ensures all documents are accessible from all EC2 instances. This solution is scalable and easy to manage, right? So option number, this one is 3 is the correct answer of this question. Okay, let us move to the next question. I think this is the last question. Yes, this is the last one. A gaming company is developing a mobile game that streams score updates to a backend processor and then publishes it publishes results on a leaderboard. The company has hired you as an AWS Certified Solutions Architect Associate to design a solution that can handle major traffic spikes, process the mobile game updates in order of receipt, and store the processed updates in a highly available database. Okay, the company wants to minimize the management overhead required to maintain the solution. Which of the following would you recommend to meet these requirements? Okay, huge question. Again, you have got 4 options. It's a little bit difficult to navigate. This is option 1. Okay, this is option 2. Got it? This is option 3, and this is option 4. Okay, these are the first options. Okay, these are the last 2 options. Got it? You will get 10 seconds time to answer the question. It's not possible to think in 10 seconds. So if you want some more time to process these options, you can pause the video and take your time. But I'll provide you 10 seconds itself. Your time starts now. Time up. Now let us analyze the answers. Option 1, push score updates to an SQS queue which uses a fleet of EC2 instances with auto scaling to process these updates in the SQS queue and then store these processed updates in an RDS MySQL database. So this option is incorrect because this option uses SQS, which is great for handling traffic spikes and processing messages in order. However, using a fleet of EC2 instances with auto scaling increases management overhead, which the company wants to minimize, right? So option number 1 is the wrong answer. Option 2, push scored updates to an SNS topic, subscribe a Lambda function to this SNS topic to process the updates and then store these processed updates in an SQL database running on the Amazon EC2. Okay, this option is incorrect. Why? Because this option uses SNS, which isn't ideal for processing messages in order. Additionally, using a SQL database on an EC2 increases management overhead. We don't want that. So option number 2 is the wrong answer. Option 4, push score updates to Kinesis data streams, which uses a fleet of EC2 instances with auto scaling to process the updates in Kinesis data streams and then store these processed updates in DynamoDB. This option is also incorrect because this option uses Kinesis data streams, which is great for handling traffic spikes and processing updates in order. However, using a fleet of EC2 instances with an auto scaling increases management overhead. We don't want that. So option number 4 is the wrong answer. Option 3, push scored updates to Kinesis data streams, which uses a Lambda function to process these updates and then store these processed updates in DynamoDB. Okay, so this option is correct because this option uses Kinesis data streams, which can handle high traffic and process updates in order. Using a Lambda function for processing reduces management overhead, and storing updates in DynamoDB provides high availability. Okay, these are the reasons why option number 3 is the correct answer and the others are wrong. So that's it for today's video. Congratulations for answering 5 questions today. We have more questions like these for Cloud Practitioner as well, and more of these for Solutions Architect as well. You can go check both the playlists we have in our channel. And I'll take your leave now, and I'll meet you in the next video with a new set of questions. Till then, keep learning, keep practicing, and keep exploring. Thank you, and bye-bye.